All right, on number 6, we have a hypothetical cube that grows so that the length of its sides are increasing at a rate of 3 meters per minute. How fast is the volume of the cube increasing when the sides are 4 meters each? So this is a related rates question because we're talking about, we see actually the word rate in here, and we're talking about kind of how fast, one rate is increasing while another one is a certain value. And so when we have a related rates question, remember the first thing we want to do is identify the shape. So here we have a cube, or sometimes it's not necessarily a shape, but we want to identify kind of the situation and the variables. And so what we know or want to relate about the cube is the length of its sides and the volume, right? So those are the things that we're going to be relating. And so we want to find an equation that fits that situation, right? So the volume of a cube where the sides are part of the equation. And luckily for us, we have such a formula, right? Remember that volume equals side cubed. Make sure you have that in your notes on the test. And yeah, S represents the number of, or the length of each side, and volume, V represents volume. Okay, just to give us an image of this, we have this cube, which um, remember that in the cube, all sides are the same. Mine is not necessarily drawn to scale, but you know that this side is the same as this side, is the same as this side, right? And so as the sides increase, the volume is going to increase at some rate as well. Okay. So the first thing we're going to do is we're going to derive on both sides. So we're going to ddt it. So we're going to take the derivative with respect to time. And so the derivative of volume with respect to time, or the derivative of v with respect to time is v prime, right? Remember v prime stands for dv dt. And then on the right side, when we take the derivative of s cubed, we're going to get 3s squared times s prime, right? That's because of the chain rule and what we do with implicit differentiation. And remember that s prime stands for ds dt. Okay, so now we have three variables, right? We have the v prime, the s, and the s prime. And so we want to plug values in for those variables. I'll probably plug in for 2 and solve for the other, right? So they give us a few different numbers here. So here they tell us the length of the sides are increasing at a rate of 3 meters per minute, right? So whenever we have a per situation, or whenever they use the word rate, that means that's going to be one of the primes, right? So it's either going to be v prime or s prime. And it says the lengths of the sides are increasing at that rate, right? So that means that this 3 is going to be s prime, the rate of change of the length of sides, right? So we're going to put in 3 for s prime, okay? And then it says how fast does the volume change? Okay, so they're asking about the volume, how fast the volume changes or is increasing, and so they're asking for v prime, right? So v prime is what we're looking for. Okay, so we're going to leave v prime as it is because we don't know it. And then it says when the sides are 4 meters each, right? So when the sides are 4 meters each, that means the side s is going to equal 4. So that's what we put in for s. Okay, so now we plug everything in. So it's going to be v prime equals 3 times 4 squared times 3. And then we just work that out, right? So exponents first, right, PEMDAS, so that's going to be 16. And so it's going to be 3 times 16 is 48. And 48 times 3 is going to be 144. All right, so that's our v prime value. And you can do that in your head, on your calculator, on paper, however it works best for you. And then the last thing that we don't want to forget is units, right? So we're talking about the rate of change of volume. And in this problem, they've given us meters and minutes, right? So minutes is the time value, so we know it's going to be per minute, right? And so now we just need a volume value on top. So volume is cubic, right? And so it's meters, so it's going to be cubic meters or meters cubed per minute. Okay, so those are units. And we we have our value, so that's the rate of change of volume. So if the sides increase at a rate of 3 meters per minute, and when the sides are 4 meters, then the volume will be increasing at 144 cubic meters per minute, which is pretty interesting. Okay. All right. Let me know if you have any questions on this one.